Yo, I am here with your 41, 42, 44, and 46 test review. I hope it helps, and I hope you like it. This is write your answer in the space provided. Attach your work on a separate sheet of paper. Alright, so after 2 years, the remaining mass Y in grams of 20 grams of radioactive element whose half-life is 31 years is given by this equation right here. So the equation is already given to us. We simply just for t is greater than or equal to 0. So it says how much of the initial mass remains after 124 years. So this one, t is already given to us. All right, we know t is 124. All right, 124. So we simply just plug it into the equation. Alright, when we do so, we're going to get 1.25 grams. Oh, that's all messed up. 1.25 grams. Alright, 1.25 grams. Okay. Should have put that on the line like the paper said. So I'm going to do that. Alright. This problem right here says, after 2 years, the value of a car, which originally cost $18,500, depreciates, so that each year is worth 5/6 of the value of the previous year. So it says find a model for V of t. Alright, the value of the car after t. So remember, right here, we're thinking about decaying. Alright, it decays at a rate. It decays at a rate. This is the initial value. Ooh, sorry about that. One too many zeros. This is the initial value, and it decays at a rate of 5/6 per year. Okay, 5/6 per year. So V of t, I should have wrote it V of t, not y. It would be this equation right here. So you put that on the line. All right. Remember. Alright, and this is just real simple. This number right here is greater than 1 is a growth, and this number is less than 1 is a decay. Alright, now it says, what is the resulting balance if $6,300 is invested for 10 years at an annual rate of 9.8% compounded monthly? Alright, so a couple things we need to know right here. That equation is going to be A equals P times 1 plus R divided by N raised to the N times T. Alright, and so we see that we have P, alright, because it's what's the resulting balance if $6,300 is invested. So our initial investment is $6,300. T is time, which is 10 years. R was 0.098. Alright, and N equals 12 because it's monthly. Alright, so that means 12 times a year. So A is going to equal $6,300 times 1 plus R, 0.098 divided by 12, raised to the 12 times 10. And again, you can put this straight in your calculator how it looks. Alright, so when you do that, you're going to get a whopping $16,719.40. Alright, I just round it up. Alright, round up right here to the nearest cent. Okay. Number 4 says how much interest will be earned. Okay, how much interest will be earned if $4,500 is invested for 6 years. Alright, so $4,500 investment is invested for 6 years at an annual interest rate of 9%, compounded continuously. The key word right here, or the key phrase, is compounded continuously. So that right there. Instead of 9% compounded quarterly. Instead of 9% compounded quarterly. So we got a couple of things we got to do in this problem. The first thing we need to do is we need to find the let's find the compounded quarterly amount. So if I invest $4,500 times 1 plus 0.09 divided by quarterly is 4 raised to 4 times 6. Yeah, 4 times 6. Then that is going to give me $7,675.95. Now, if I compound it continuously, E raised to R times 6, that is going to give me 7,722.3. All right. Well, it says how much interest you earned if it was compounded continuously instead of compounded quarterly. All right. So what we need to do is find the difference of the two. So I'm going to do 7,722.03 and subtract $7,675.95. And what I get is $46.08. All right, $46.08. So that would be the difference right there. Okay, $46.08. Now, for this next question, it says what lump sum should be deposited in the account. So we're looking for the premium here to the account that will earn your annual interest rate 10% compounded quarterly to grow to $170,000 for retirement. All right. So for or in 25 years. So for this one, we're going to use the same equation we used above for compounded interest. All right, but this time we got A. So A is 170,000. P we don't know. That's what we're looking for. T is 25, and N is going to be 0.1 for 10%. So we have 170,000 equals P times 1 plus 1 plus 0.1 divided by quarterly. Man, that's R, y'all. Sorry. R is 0.1. N is 4. I'm rushing. So 0.1 divided by 4 raised to the 4 times 25. There we go. So what we need to do is we can actually simplify this, or we can just divide it out. So I'm going to do this. So 170,000 equals P times, I simplified this right here, everything parentheses in the exponent, to get 11.81371635. I just wrote the whole decimal down. Alright, but anyway, if you divide by that, alright, I'm going to do it over here. 11.81371635. Alright, and I did that to have a more precise answer. Alright, then I get P isolated, and it equals 14,390.05. Alright, 14,390.05 would be P. That would be your investment. Alright, for 25 years at 10% interest, compounded quarterly to have 170,000 after 25 years. Alright. Right here, it says to help their son buy a car on his 20th birthday, a boy parents invest $800 on his 8th birthday. If the investment pays an annual rate of 9% compounded continuously, alright, how much is available on his 20th birthday? So this is A PERT. I want to use this equation right here. Oops. Alright, A PERT. Alright, where in this equation right here, 800 equals P. T. All right, let's calculate T. So if they started on his 8th birthday, and they're gonna buy the car when he's 20, right? So this is 20th birthday. 20 minus 8 is gonna be 12. So 12 years. So T equals 12. All right, and so our rate is going to be 0.09. So now we just plug everything into the equation. Okay, how much is available on his 20th birthday? Well, A equals P E raised to the R times 12. And when we do that, okay, we can just plug it in and solve it. We get $2,355.74. So that's how much money is in that account. Okay. Number 7 here. It says on a high school campus, let me zoom out so you can read this. On a high school campus of 2,000 students, a single student returned to campus affected by a disease. The spread of the disease through the student body was given by this equation right here, where Y is the total number of infected at the time, T in days. All right, how many people were affected after 8 days? So this was really simple. The equation is given to us. All right, I zoomed off. So 2,000. This one's going to be Y equals 2,000 divided by 1 plus 1999 e to the negative 0.99 t. And in this case, t is 8. Alright, t is 8. So I plug in my 8 right there. And then we punch that in our calculator. Now remember, in your calculator, guys, it's kind of finicky. So you got to make sure you put parentheses around this whole denominator. I would. All right, just to be sure. When we do that, you get 1,158. Hold on, let me check. All right, 0.45. And since we're talking about the population of people, I'm going to round this to the nearest whole number. So 1,158 students. All right, I don't want 4/5 of a person. Alright. Let's see here. Looks like we got some natural log here. Write the logarithmic equation in exponential form. So remember the conversion here is when you have a log base B of A equals E. When you convert it, is B to the E equals A. All you do is from a log, alright, or even natural log, the B is now your base, the exponent goes up, and you swap these two, alright, like that. So right here, to write this, you would get E to the negative 0.1054 equals 0.9. Alright, that's what you would get. Alright, and also just remember, just showing you, if you E both sides, see, then 0.09 equals E to the negative 0.1054. So that's what you get right there. Okay, and then for this one, alright, we need to convert this exponent to a log, so you can natural log both sides, and you'll see that 10 equals the natural log of 26.47. So right there. Okay. 10, simplify. Okay, simplify it. Remember the property right here. Natural log and E are inverses, so they cancel out. So I'm just left with X. So in this case, natural log and E cancel out. I'm left with 3X and 4. Here, again, e and natural log are inverses. They cancel out, so 10x to the fourth. Number 11, use the property of logarithms to expand. So when it's division, remember that rule tells us that we can subtract with respect to the natural log. Alright. Number 12, use the property of logarithms to expand. So first of all, remember we have an exponent here. This needs to go out front. So that's 4 natural log of, I'm going to write everything out because I think it's good when you see it. Now, here's the division again. Okay, this is division again. You got this top, this bottom. So you have 4 natural log. Alright. And then we have natural log of x squared minus 16. Now it's natural log of x squared minus 16 minus natural log of x cubed. Okay. If you want to take a step further, which you actually can, you'll see that you get 4 natural log of x squared minus 16. But I think here is sufficient. I might push it to there. 13. Alright, the multiplication property. We first need to rewrite this. Well, we're good. Let's so this is x times the cube root of that. So I want to rewrite this as ln of x times x squared plus 6 to the 1/3. Now, when we take the natural log, you have ln of x plus, because it's multiplication, natural log of x squared plus 6 to the 1/3. And now the last part is this 1/3 can come out front like that. So natural log of x plus 1/3 natural log of x squared plus 6. Alright, number 14. Use the property of logs to write a single logarithm. So again, subtraction right here, natural logs, we got subtraction in the middle. Well, that means we can divide them like we did up top. Well, we're just doing what we did up top. Alright, here, a couple things gotta happen. We need to put that 4 back here. That 6 needs to go back to the exponent, and this 4 right here. So you end up with natural log of x to the 4th plus natural log of x plus 3 to the 6. Uh-oh, ran out of space. Alright, there we go. Had to get that. Natural log of x minus 3 to the 4th. Now, you see how this right here says plus? So you got x to the 4th times x plus 3 to the 6, because this tells us that if I'm condensing it and it's a plus here, I can multiply those two. So I'm going to multiply those two. X to the 4th, x plus 3 to the 6, and this is subtraction. Alright, so that tells us that we need to divide that out. Alright, for this one, we need to write it as a single log. Alright. And again, there's the directions right there. Write the expression as the logarithm of a single quantity. So we're going to do the same thing. We're going to put the 2 back here. I put the 1/4 back here. So you have natural log of 5 squared minus natural log of x squared plus 4 to the 1/4. Alright, and now we need to just, since there's a minus here, we can divide it. So we get natural log of 5 squared divided by x squared plus 4 to the 1/4, which we can actually rewrite that as 25 over the 4th root of x squared plus 4. So you can write that as 25. That's it right there. I don't know why my page, now that I'm looking at this, just came out. Alright. Here, I'm going to do this one over here. Same thing, right as a single log. So we're going to put that back and put that back right there. So ln of x squared minus, or natural log of x squared plus 9 to the 10th. Alright. And now subtraction tells us, again, we're going to divide that out. Alright. So we're going to go natural log of x squared divided by x squared plus 9 to the 10th. Alright, division. The minuses divide those two expressions. Alright, this one, same thing. Same as that thing. That here. This is reiteration, guys. Good reiteration. So you have natural log of x minus natural log of x squared plus 1 to the 10th. And then minus says we can divide them. X squared plus 1 to the 10th. Alright. Natural log of x over x squared plus 1 to the 10th. Alright, number 19. Solve the exponential function. Okay, we got to solve here. So first, I'm going to subtract 550 from both sides. Alright, we need to get this by itself. So when we do that, we're going to get a negative 450. So we're going to now divide by negative 890. That's going to reduce. I'm just going to simplify that to a positive 45 over 89. And that equals e to the negative 0.1x. And so if I natural log both sides, because I'm going to get rid of that e. Alright, that cancels. Okay. And then we should divide both sides by a negative 0.1. Alright, and that'll give us an x. So when we do that, it's going to give us a 6.8197. So we'll do 8.20. Okay, now let's look at this one, number 20. Number 20 says solve the following equation for x. So, same type of problem. Right here, I'm going to start by dividing by negative 6 on both sides. So you have 10 to the 5x minus 4, which equals 5. That's positive because they're both negative. So 590 divided by 6. These are both negatives. Now, because I can't solve this way, right? I can't. This is an exponent. I need to convert this to a log. Alright, so this goes back to writing this. So you get log base 10 of 590 divided by 6 equals 5x minus 4. And so now let's isolate x. So I'm going to start by adding 4 over here. So you have log base 10 of 590 divided by 6 plus 4 equals 5x. And then divide both sides by 5. So x equals log base 10 590 divided by 6 plus 4 all over 5. And let me show you how to put that in your calculator. Alright, so putting this in, we're going to go log, alright, and I'm just going to leave this log because it's already log base 10 on your calculator. So we do 590 divided by 6, alright, and then we're going to go plus 4, and this is the top, so I'm a firm believer. Around my entire top or my entire bottom. So that's the top. And then we're going to divide that by 6. Oh, I'm sorry, divide that by 5. Sorry. So I'm trying to divide by 5. And there we go. We get 1.19. There we go. Alright, so for this problem here, a sample contains 4.9 grams of radium after 10,000 years. Our radium has a half-life of 1,599 years. Determine the initial quantity of radium. Alright, so we got to find the initial quantity, which is C in these equations. If you remember, we did the equation Y equals CE to the KT. Alright, well, we don't know what C is. We don't know what the initial quantity of radium is. Alright, but here's what we do know. We know that it takes 1/2 of C, we know we'll have half of C in 1,599 years. Alright, so we can use that find K. Alright, so if I divide by C on both sides, then I'm left with 1/2 equals EK to the 1,599. Now, let me rewrite that. 1,599. Now, we got this E. Now, how do you get rid of this E? Well, we're going to natural log both sides. So you have the natural log of 1/2 equals 1,599K. And so now we just isolate K. And we get K equals negative 0.00043. Alright. Now all we do is to find our original amount. We go, the sample contains 4.9 grams of radium after 10,000 years. So we know we finished with 4.9 grams. Alright, after 10,000 years. How many years? Oh man, I got that fast. 10,000. Oh my gosh, right, 10,000 years. In my face. I'm getting sleepy. Alright, so anyway, we need to solve for C. So to solve for C, all you do is divide out this number right here. Yeah, divide that out on both sides. Alright, so again, that's something we punch in the calculator right here. 4.9 divided by e to the negative 0.000433 times just like that. And there we go. 372.13 grams. 372.13. So that's how much radium is left. Alright. That's how much radium is left. Alright. Let's keep going. We're almost there. Alright, so for number 22 here, it says money is deposited in an account for which the interest is compounded continuously. So compounded continuously means we're going to use APERT. Alright, the initial investment in the account is $4,000 and the annual interest rate is 13%. Alright, what is the time required for the balance to double? Alright, so we're looking for the time it takes for the balance to double. So in this case right here, look, we want to double that amount. So we already know for a fact. We're looking for time because that's what it asks for. It says how much time does it take for that to double. So what we're going to do is A is going to equal, let me make this bigger so I'll have more space to write. A equals 4,000 E to the 0.13 times T. We're looking for time. But in this case, what is doubling this amount? Well, we know then A is going to be 8,000 because we want to double it, right? We want to double it. So now we just solve for time. So I'm going to divide by 4,000 on both sides. Alright, so that's 2 equals E to the 0.13 T. Now, we learned that the inverse of E is ln. So if we take the natural log of both sides, the inverse is natural log. I don't know why I said ln, but if you take the natural log of both sides, all right, the natural log of 2 equals that they're going to cancel 0.13 T. And now all we got to do is divide by 0.13 on both sides. And that'll give us our T. So I'm going to punch that in the calculator real quick. Natural log of 2 divided by 0.13. And it gives us 5.33 years. 5.33 years. All right, now let's look at this next problem. It says money is deposited in an account for which the interest is compounded continuously. So again, same equation. The initial investment of the account is $800. The balance of the account doubles in 7 years. What is the annual interest rate? So this time we're looking for the R. All right, same type of question. All right, we know that it doubles in 7 years. All right, so if we put 800 in there, then that means we're gonna have 1600 in there when it doubles in 7 years. E, we don't know what R is, but we know T is 7. So I'm gonna put 7R. 7R, there we go. Okay, so I'm gonna start by dividing by 800 again. Oh, 800, sorry. So we get 2 equals E to the 7R. And so we need to do the natural log on both sides again because that's the inverse. That will cancel out the E here. All right, and then we're gonna just divide by 7 on both sides. So ln of 2, natural log of 2 divided by 7 equals R. All right, so I'm gonna go to the calculator again. Natural log of 2 divided by 7. And about a 9.9% interest right there. All right, because yeah, about 9.9 equals 0.099 or 9.9% interest right there. That's our interest rate. Okay, let's rock with it. Number 24 right here, the effective yield is the annual rate. Oh, you know what? Here, let me show you how to do this same question. If you didn't have the initial amount, you could find R2. We did this in class. So let me backtrack real quick. I want to show you how to do this because let's say hypothetically you got a question on the test and it didn't give you your initial amount, so you didn't know what it would double. So you have your equation. I'm going to write on this line right here. Right? Well, let's say I didn't know what the initial P was. All right. Well, what I could do is if I wanted to find my interest rate, I could let A equal 2P. So I'd say 2P equals PERT. Okay. And then I divide by P like we did over here earlier. So you still end up with 2 equals ERT. And they told us T was 7. So we got that. T was 7, so I should put 7. So I'm going to go back and do that real quick just so you have a reference. Alright, R. Oh man, it's changed on me. Alright, there we go. R times 7. There we go. So, alright, yeah, 7 years. So now we can do the same thing by natural log both sides. You'll see that cancels. So you have natural log of 2 equals 7R. And then again, still divide by 7. So you see how we end up with the same thing? All right, we end up with the same exact thing. And again, I'm showing you this because let's say they didn't give you your principal and you didn't know what the double value was. Okay, you can still find it. So you still get 9.9%, okay? So make sure you have both of these written down because you might see a question like this where you got to solve for R without having your P. All right. Couple more. 24 here says the effective yield is the annual rate I that will produce the same interest per year as the normal rate compounded n times per year. All right, for a rate that is compounded n times per year, the formula for effective yield is here's the equation right there. Instead of putting I right here, we usually put this right here. All right, so you know what I'm referencing. Instead of I, we just put that there. It says find the effective yield for a normal rate of 7% compounded monthly. So I'm going to write it like this so you can see it. All right, and you have 1 plus the rate is 0.07. It says compounded monthly, so n is 12. Raised to the 12 minus 1. Now this is not the exponent minus 1. That is this body right here minus 1, okay? So this is something, again, you can just punch right in your calculator. Alright, so we have 1 plus 0.07 divided by 12. Then we raise that entire exponent to 12. Alright, now don't make it an exponent again, okay? Make sure you subtract 1 as a whole number. And you get 7.2%. Alright, so we got equals 0.0722. So 1.7.22%. And so now 25 right here. 25 says, given the piecewise function, find f of -3. Well, we see right here, let's look at just this first portion. This is a good question. For this right here, this equation, remember these are equations, and these are constraints. So for this constraint, here's the equation, here's the constraint. For this constraint, x has to be less than -3. So we're talking about like -4, -5, -6, -7, -8, right? Those numbers are less than -3. So we're looking for when x equals -3, right? Well, we can't look at this equation because this equation only applies to numbers that are less than -3. So we're not going to look at this one. This one, okay, this one, the constraint is between or equal to -3 or 5, all right, between -3 or 5 or equal to -3. You see that, the equal to? So we're going to look at this equation right here, okay? We're going to look at this equation right here because it is equal to -3, okay? So what we do is f of -3, we can evaluate that. All right, I don't know why that's there, but those 3's are canceled, so you're just left with -5. All right, so y would be -5. And that's all you do is just evaluate it, okay? We wouldn't look at this one because -3, these are x values that are larger than 5. So -3 is less than 5, so we wouldn't look at this either, okay? Now, hypothetically, let's say I said, what is f of 1? All right, I'm just throwing this in there as a wrinkle. If I said, what is f of 1? All right, well, you would have to look again and go, okay, 1 is in between -3 and 5, so you'd use this one. And you'd evaluate it and get 5/3. All right. Well, if I say, hey, what is f of -7? Well, let's do -9. That way we have a better number. All right. If we said f of -9, you'll see -9, that's my x value. That's less than -3, right? So I would look in this space right here. All right, I go -4 times -9 squared, right? I should have remembered, but it's all good. All right, so you get 81, and then 81 times -4 is going to give us -324. So the answer would be -324. All right. For this condition here, if I said, hey, let's find f of 7, right? 7 is greater than or equal to 5. So the answer would be 1. All right, because there's nothing, the function just, the y value is 1 for any x that's greater than or equal to 5. All right, even if I said f of 5, all right, well, I wouldn't look here because these have to be less than 5. So 5 is not included. I can't plug that in here. But right here, 5 is equal to 5. So I would plug it in, and there's nothing to plug in. It's just y is 1. So just showing you that little tidbit. Now, lastly, we got this piecewise function right here. We did a great deal of graphing on these. Hopefully you finish your assignment. But we need to graph these piecewise functions. So for the first function, -4, what is y? So right here we want any x value less than 0. So I'm going to start with 0, of course. I plug in 0. Well, there's nothing to evaluate. The y value is -4. All right. Then I pick a value that's less than that. So let's say -1. Again, it's still -4. If I did -2, it's still -4. So I'm going to graph these points. But the thing here to remember is x is less than 0, which means it's an open circle at this point. Right? At 0, -4. So I go to 0, I go down 4. All right, 0, -4. So 1, 2, 3, 4. I'll put an open circle there. And then I'm going to shade. I did that in red, so I keep it here. I'm going to shade this way. It's not quite enough. Let me fix it. Alright, see, so for every x value less than 0 is going to be -4. Now, for this next one, the next function, let's change the color. 5. Gotta change it. Five thirds x is the equation, and then you have y. So we need to pick x values between 0 and 3. So I'm going to go 0, of course. Alright, so I plug in 0 is 0. 0 times 5 thirds is 0. If I plug in 2, let's plug in 2. We'll do 2. I plug in 2, you get 10 thirds. And then if I plug in 3, I get 5. Alright, so now, see how right here when I plug in 0 is equal to, so this is going to be a closed circle. And if I plug in 3, alright, I get 5. Well, it's not equal to 3, it's an open circle. Alright, so at 0, 0, I have a closed circle. And at 3, 5, I have an open circle. Alright, there's my segment right there. So I'm going to put a segment over here. There's my segment for that one. And then let me do one more color for the last function. So for any x greater than 3, so I'm going to start at 3. The answer is 1 because there's nothing to substitute here. And this is going to be a closed circle because it's equal to 3. So 4 is still going to be 1. Even if you do 5, it's still 1. Alright. So I started at 3, 1. I put my closed circle. And then any x value larger than that is going to be 1. Alright, so I'm going to put my line on the graph like such. So there we go. There's your piecewise function graph. Man, again, it's kind of lengthy, but hey, I hope you do well on your tests, and good luck.